Okay, let's get started. We're going to start our Chapter 2 section. Actually, we're going to start it with Section 1.7. Chapter 2 is a little bit shorter than Chapter 1 was, so we'll split it up a little bit and add Section 1.7 into our Chapter 2 kind of unit in general, and it'll be on the Chapter 2 test. So, getting started, we're going to solve intervals and inequalities. So we'll start by using interval notation. Alright, what this is, a closed interval is denoted with our square brackets here, and an open interval is denoted with our parentheses, and you can mix and match them. So what this means is if we were doing our old graphing on a number line, and we said that x is greater than 5, and we said 5 is right here, this would have been an open circle, and we would have pointed this way, okay? The way we would use interval notation is the open circle matches up with the parentheses, meaning we can get close to 5 but never touch it. This, if we went forever, we would go to infinity, and you can get close to infinity, but you can never touch it either, so that would have to be an open parentheses. If we change this to an equals and filled this in, we would change this here to a square bracket. And so then you can see all of the examples here. Let me erase this so it's not covered up. Okay. And so you can make a note of that if you want to pause the video and copy that down if you like. I don't think it's necessary as long as you understand that the square bracket is for equals to and the parentheses is for less than, greater than, but not equal to. And then going the other direction, if you have the interval notation, you can turn that into the graph, and the parentheses here would be the same as an open circle, and the square bracket the same as a closed circle. Okay, so let's see if we can do this. If we have -2 is less than or equal to x is less than or equal to 4, we're going to say bracket -2 to 4 square bracket. 2 is less than x is less than 7, we're going to say parentheses 2 to 7 parentheses, because we're not equal to 2 or 7. Greater than or equal to 6, we can touch 6, but we can't touch infinity. And less than -3, we're going to say negative infinity, because we're going all the way below -3, all the way up to -3, which we can't touch, so parentheses. Let's try going the other direction. So if we start with the interval notation, can we graph it? Number line -1 would be an open circle, and the 2 would be a closed circle, and we would shade in between. You can also do this like this, -1. You can use the bracket like that, and 2, you can use the parentheses. Okay? Either way is fine. You've just been doing it this way for a long time, most of you. All right, what about 5 to infinity? 5 on the number line, open circle, and off we go forever to infinity. -2 to 0, -2 closed circle, 0 closed circle, shade in between. And negative infinity all the way up to 1 with an open circle, and so we'll be going that way forever. Alright, so 3 for you to try with that new information. Try problems 11, 21, 29. Pause the video and come back when you are ready. Check the answers in the back of the book. Alright, second objective, use the properties of inequalities. And so a couple properties here. Now, if you square any number, excuse me, if you square any number, you're going to be greater than 0. We've been working on that with our square root properties. Okay, now if you take an inequality and you add the same number to both sides, the inequality holds. So, if you start and say x is less than -5, if you add 5 to both sides, that's allowed, and now you can say x plus 5 is less than 0. So you can move this to the other side, just like in a normal equality if you change the sign. Same thing here. We could say x minus 2 is greater than 0 instead of x is greater than 2. Works both ways. All right, try problem 37. All right, same thing here. Multiplying by a positive works as well. What is 2 times 3? 6. What's 5 times 3? 15. Is 6 still less than 15? Absolutely it is. So we're allowed to multiply both sides by any positive number. Not by negatives, though. What's 6 times negative 2? That's negative 12. 4 times negative 2 is negative 8. And now, which one is greater here? Let's see. Negative 12 is less than negative 8. 6 is greater than 4. Okay, so you notice that the inequalities here need to switch. So anytime you multiply by a negative or divide by a negative, you need to switch your inequality. So this is that written out. If a is less than b, if you multiply by something less than 0, switch your inequalities around. All right, so this walks through that. You can multiply by a fraction and keep your inequality. But if you multiply or divide by a negative, switch yourselves around. So knowing that, try problem 43. All right, third objective. We're going to solve linear and, inequalities algebraically and then graphically as well. All right, so it's going to give you these steps. These steps here are just normal solving steps. And they're just saying that if you've got x plus 2 plus 6, consolidate on one side, distribute on the other, right? Clean up each side as best you can. Then what you want to do is try to get all the x's on one side and all the constants on the other so you can get 4x greater than 16. And then divide like you normally would. So steps for solving stay exactly the same as a normal equality, unless, of course, you are multiplying or dividing by a negative. Okay, so you don't want to do that. You can always switch sides, but if you do that, the inequality switches. So remember, if x is greater than 3, x is greater than 3. You got to move this inequality around if you switch sides. Now, I'm going to come back to this, but we can graph this on our graphing calculator and compare the inequalities. You can do that, but you would just graph y1 and y2 separately, but on the same screen. And we'll talk about this later when we're graphing. So just know that this is here. We're going to come back to it. Okay, first things first. Let's solve this inequality algebraically. So 5x minus 7 greater than or equal to negative 3x plus 1. We're going to get all of the constants on one side. So let's add 7, add 7. Let's get the variables on the other. Add 3x, add 3x. So we've got 8x greater than or equal to 8. Let's divide by 8. X is greater than or equal to 1. And we are in business. Okay, let's check how we would do this graphically. Pull up the graphing calculator. Y equals, clear this off. All right, 5x minus 7 goes in for my y1. Negative 3x plus 1 goes in for the y2. I'm going to graph these. And clearly I don't have a very good zoom set up here, so let me change that to our zoom standard. Okay, so there's y1. Going up is the 5x plus 7. Coming down is the negative 3x plus 1. All right, so we need to know where is this line greater than this line, right? Because it's greater than or equal, so where they touch. So it looks like right here, right there, where they cross, okay? And everything going, as soon as I go this way, this line is bigger than this one. And by bigger, I mean higher up, because bigger y values mean is better than a lower y value, right? We're higher than it, so we would be the same as greater than. When you're talking about greater than on the graphing calculator, you're comparing the y values for each line. All right, so where would these cross? Let's use our intersection. Haven't used that in a little while. The intersection of line 1 with line 2, we think it happens right about there. And there it is. X is 1. And so at 1 we intersect, and everywhere bigger than that, greater than 1, the left side is going to be bigger than the right side. All right, so a little longer. Most of the time you're going to do these algebraically. It's good to know that you can do them on the graphing calculator. For some things, we'll do it down the road in math. Try problem 49. See if you can do that on your own. All right, objective 4, let's solve combined inequalities. Okay, so these get a little tricky, but I think you'll be okay once you do a few of them. combine inequalities, we're going to get x by itself by minusing 1. And whatever we do there, we do to all three pieces. So now we have negative 5 is less than 5x is less than 10. To get x by itself, divide by 5. We need to do that everywhere. Divide by 5, divide by 5. Negative 1 is less than x is less than 2. And in the back of the book, it might say this, negative 1 comma 2, because that would be interval notation. You could see either thing. You can write either way as your answer. All right, to graph the solution, there's negative 1, open circle. There's 2, open circle. Shade in between them. Try 65. All right, last objective here, I believe. Solve absolute value inequalities algebraically and graphically. Okay, two different things happen with absolute value. Let me start this. I'm going to pretend for a second that this is absolute value of x equals 8. So the answer here is x equals 8 or negative 8. Okay, so let's put that on the number line. Negative 8 and 8. They're going to be open circles because I don't see a equals to. That's not there. But the question is, should we shade in between those two circles or outside of them? And I want you to think about absolute value as distance. How far away you are from something. If your distance is less than 8, you could be 7 or 6 or 5 or all the way down to 0. And you could be to the left or the right. So it doesn't matter if you're positive 1 or negative 1. That's less than 8 in the absolute terms. So a less than, you're going to shade between, because your distance is less than whatever number is put up there. Okay, so that's what this says here. Let's try this one. 3x plus 1 is less than or equal to 7, so 3x plus 1 is less than or equal to 7. Or, and here's a bit of a twist, 3x plus 1 is greater than or equal to negative 7. Let's solve. Minus 1 all over the place. 3x is less than or equal to 6. 3x is greater than or equal to negative 8. X is less than or equal to 2. X is greater than or equal to negative 8/3. If we were to graph this, it would be in between negative 8/3 and 2. Okay, so this is an and. It happens in between them. Pause a second, try problems 77 and 79. Okay, last thing to look at. What happens if the absolute value is greater than 5? Then x is going to be greater than 5, or x is going to be less than negative 5. Graphically, less than negative 5 goes that way, bigger than positive 5 goes that way. This is an or, not an and. Okay, so if you're greater than, you're outside. Or is the word you're going to use. Okay. Let's try one where we don't just have x by itself. 2x minus 3 greater than or equal to 4, or less than or equal to negative 4. Let's add 3. 2x is greater than or equal to 7, or less than or equal to negative 1. Let's divide 2 everywhere. And so x is greater than or equal to 3 halves. I'm sorry, 7 halves, 3 1/2, or less than or equal to negative 1/2. So there's 7 halves, close circle. We're greater than that, or we're less than negative 1/2. Okay, we're going outside. We're further away, not closer to on those. Okay? All right, so that'll do us for 1-7. Make sure you've done all your problems, and any questions, we'll go over them in class. Good luck.